Now we will discuss about how to copy the sequence and how copy effect when we copy a sequence, right? First we'll discuss about the shallow copy. Basically we'll discuss about two type of copies, shallow copy and the deep copy, right? And now first let's copy the element based on the simple loop. Again, this is not the good approach, but let's do this. Here we have this L1 is list. Now to copy the element, we have created the empty list and then we have taken the for loop of this L1 and then we have appended all the element of the L1 to L1 copy. So basically L1 and L2 have the same object. Here we can see that L1 copy has also the same object. As we can see that this L1 and L2 are not the same. Again, to check whether this both are the same object or not, we can use the is operator. Here we say that L1 is L1 copy. This means that we are saying that whether this L1 memory address of L1 and the memory address of L1 copy are pointing toward the same or not, pointing toward the same object or not. Basically, we are trying to check that whether this memory address of both objects are same or different. If it is different, we'll get false. If it is not, then we'll get true over here. We'll get false. So L1 address and L1 copy address both are different. We can also do the same approach with the help of list comprehension. It's a little easier approach. Here we are taking this entire loop inside a list only. So here we are saying that for item in L1 and then we are copying that item over here. So this is like we are just copying the element. This is a one way to, so this technique is called the list comprehensions, right? So this is another way to copy the element. So here we can check that, and again once again objects are not same. We can see that both objects are different. And we can also use the copy method. Like list has a copy method because it is mutable. So here we have this L1 is a list, and then we can use L1.copy to copy the element, or to copy not element but to copy list in this variables. And then when we try to check the value, here we have this. Again, when we check the is operator, we'll get false, right? Because we are copying the element and both list will be different, right? Now using a built-in list function. So here we have the list function. This will also create a list. So let's check this. Here we have this L1, which is a list, and then to copy this L1 we can use the list function. We say that list and then we pass the sequence data. Remember, here we can pass any sequence data, not just list. We can pass tuple, dictionary, we can pass this set, any, we can pass string, right? Any sequence data we can pass over here, and then it will generally convert those sequence data to a list. In this way we can also create a list, and when we check the is operator we are getting false because both lists are different, right? Here we are passing the tuples, right? Now when we use a tuple or a tuple function to convert any object or copy the object, like over here we have this t1. Like here we have seen that this both lists were different, but let's see the tuple. We have this t1, so this is a tuple. Now we are using a tuple functions to copy this tuple. Here we have this. Now when we see, let's check the is operator. So this will give me true because tuple is immutable, right? And it generally does not create another object, right? Let's check with the slicing. When we couple or when we copy the element using slicing, here with the list, right, we have already seen this before. With the list we are using the slicing of this list, and this way we are trying to check the copy. This will give me false. And now let's again check with the tuple what the behavior it shows with the tuples. With the tuple it says that true. That means both objects are same. It is not creating a different object. It's like different variable pointing to the same object. So as we can see that slices was entire tuple, right? And the copy we have not done, like this copy we have done is not a copy, right? It is pointing, it is referencing to the same location, same memory address. Again, Same thing happens with the string as well, because string is also immutable. Here we can see that with the str function we are creating a copy and the objects are same. Same thing we can do with the slicing. Still both objects are same. So why this Python is doing so? So if you create a copy of tuples, so what you will do with the copy actually? So it's like, if Python thinks that even though if you create a tuple, even though if you create a copy of that tuple, you are not going to change it, so that will not make sense to create another object. So Python does this automatically for you. So this is an optimization process that Python do this, right? But this is not happening with the mutable object, because mutable object, if you create a copy, you can create a new object, you can add it, you can remove it, you can modify that object, so it will not point to the same locations, right? So this is just the basic optimization that does Python for us. Now the similarly, we have a general copy method to copy any element or any object. For that, let's import copy, right? And the copy has a generic copy function. So here to copy this, we'll use copy.copy. You can also say from copy we can import copy, but let's do this. Here we have this list. We are using a copy to copy the list, and let's check it. Again, we are getting false. Let's do the same thing for the tuple. We are getting true over here. So copy also behave the same way, right, as we have seen earlier. So again, earlier I have mentioned there are two type of copies. One is shallow copy and other one is deep copy. So till now we have been doing as in shallow copy, right? This means that when the sequence is copied, each element of the new sequence is bound to the same memory address. That means here when we create a copy, this L1 and L2, here we have this L1 is 1 2 3, and again L1 copy has also L1 1 2 3. But both objects are a different object, but inside this object, inside this list, one and this one both are pointing to the same address. 2 and 2 both are pointing to the same address. 3 and this 3 both are pointing to the same address. So on inside objects are pointing to the same memory address, but these two lists have been created entirely. That means if you modified one list, other list will also be modified, right? So let's see that. Here we have this v1 and the v2, two top two list, and then we are binding this. Again, we are combining these two lists inside another list, right? And now let's try to print the line 1, and then we are also trying to check the ID of line 1, which is ID of this, and then we are also trying to check the ID of line 1 1. So here when we do so, we can see that because both object has been created entirely differently, this object was independently created, this object was independently created, right? So memory address of this v1 and this v2 are totally different, we can see that. But now let's create a copy of this line 1. Here we are making a copy of this line 1, right, using dot generic this available copy method, because line 1 is a list, we can copy it. So we have copied. Now we have got the line 2, and now we try to check whether this line 1 is equal to line 2 or not. Of course we'll get false, we have seen this earlier, because line 1 and line 2 are the different object. But inside these container line 1 and line 2, these object v1 and v2 are pointing towards the same memory address. We can check that. Here we are saying that line 1 0 and line 1 1. So we are trying to check the ID of line 1 for both object and ID of line 2 for both objects. Let's see that. And here what we see, the ID of line 1 of 0 position and ID of line 2 of the 0 position both are same thing, and same thing happening with the first position as well. So the internal object has not changed, they are still pointing towards the same reference, so they are still pointing towards the same address, same memory address, right? Though the outer container has changed, but internal objects are still pointing to the same locations, right? What if we change this line to, we are saying line to 0 0, that means we are changing this one v1 value at the 0th positions. So here we are saying that 0 0, right, 200. Now so line 2 will become this, so we have changed this value. Now let's try to, because both object v1 and v2 in this line 1 and line 2 are same memory address, so line 1 should also change. It will also reflect the same change which is with the line 2. We can see that, right? So if we want the contained element also to be copy, right, we have to do this explicitly. One way to do this is by taking the loop and copy explicitly, like over here. Again, we are getting the same list. Now we have created a line 2, but for this time we are using a for loop. Here we are saying that for item in line 1. So we are accessing this one, and then we are copying this one over here. So when you copy the element, it will create a new object. So these objects will change. Then after that, we can check the ID will be different, right? So once we change one object, the other objects will not affect, right? So not only, so again here we have that copy, but again inside this object, right? So let's say that here we have not copied this 0, right? If you modified this 0, right, so that will also uh, kind of impact, right? So here what we have to understand is, again, let's say that here we have this this two-dimensional matrix. Let's say that if we have the 5-dimensional matrix, right, so you have to take a loop inside a loop, and then you have to copy each element. But you do not have to do that. Python provide a deep copy function which does that, which does which entirely copy each and every objects, right? So here we can see that we have this v1 and v2. We have created line 1. Now we are using copy.deep copy, and then we are copying the line 1, and then we can check the each object. It's totally different, so deep copy will do the same thing for you. Now let's change the 0th position value of v1, and then again we check, again it has not changed, right? It can also work with the three-dimensional or the nested object. We have this line 1 and line 2, and then we're again creating another object like plane 1, which is holding line 1 and line 2. So it's a three-dimensional object. We can see that, right? It's a three-dimensional object. Now we can also use a deep copy to copy this three-dimensional object, and this will also work. We can see that the addresses are different, right? So it can even work with a different object. So again, copy and deep copy can copy any object. So it can even work with the classes. Here we have this point, the line, we have the two class. We have created this 2 point, and then we are creating a line using 2 point, right? And then we are copying the line object, and then let's try to check the individual ID. Here we can see that the individual ID of the points are totally different, because here we have used the deep copy, right? You can also see the memory address. Here the memory address are also different. But here, like here we have not used a deep copy. Here we have just done a shallow copy. When you do the shallow copy, the ID will be same. We can see that over here, right? So now you know how to copy any object, or specifically how to copy a sequence using copy and the deep copy method, shallow copy or deep copy method, right? And yeah, this is it. Thank you very much.